Number 9. The finding of Jupiter. A key part of astronomy as a whole is knowing when people first saw and documented key objects in the sky. This, of course, includes the planets like Jupiter. But as history has shown us, it's not something that was discovered recently, but rather farther into the past than you would expect. The first finding of Jupiter dates back to at least the Babylonian astronomers of the 7th or 8th century BC. The ancient Chinese also observed orbit of Suzing and established their cycle of 12 earthly branches based on its approximate number of years. The Chinese language still uses its name when referring to years of age. By the 4th century BC, these observations had developed into the Chinese zodiac, with each year associated with a Tai Sui star and god controlling the region of the heavens opposite Jupiter's position in the night sky. These beliefs survive in some Taoist religious practices and in the East Asian zodiac's 12 animals, now often popularly assumed to be related to the arrival of the animals before Buddha. The Chinese historian Shi Zhizong has claimed that Gan Di, an ancient Chinese astronomer, discovered one of Jupiter's moons in 362 BC with the unaided eye. If accurate, this would predate Galileo's discovery by nearly 2 millennia, though obviously this is a bit up for debate. Either way though, as you can see, Jupiter has been known about in the sky for quite some time, with many different civilizations keeping track of it and the entities around it. Number 8. The seasons and orbits. In regards to our solar system, Jupiter is the biggest of our planets. It's so big you can't put 1,300 Earths into it with no issues, which means that everything just has to be bigger on the planet. Am I right? Well, no. For example, in terms of its daily orbit, it rotates on its axis faster than any of the planets that we have in our system. For Jupiter, a day only takes about 10 hours. That's less than half an Earth day, and you thought time flew on our planet. But there's a catch, because that everything is bigger line does apply to how the year works on Jupiter. Given its distance from the Sun and how fast it moves, a year on Jupiter takes 12 Earth years, or 11.86 to be a bit more precise. That means for every 12 orbits around the Sun for Earth, Jupiter will have just completed a singular loop. So as you can see, it's a bit of a trade-off. You may have faster days on Jupiter, but you also have much longer years. Finally, for the seasons, the gas giants have a bit different of a system in terms to seasons, because they are made of gas, no solid surface, and that means that their clouds dictate their seasonal outbursts as much as the Sun does. To that end, Jupiter is known to be a very stormy planet, and then when it gets to a certain point near the Sun, it can change into one area and be cold, while the other can be hot. Oh, and seasons last 3 years there, so there's that. Consider this one of the many reasons we don't see to inhabit Jupiter for now. Number 7. The moons. In 1610, Italian polymath Galileo Galilei discovered the 4 largest moons of Jupiter, now known as the Galilean moons, using a telescope, thought to be the first telescopic observation of moons other than Earth's. One day after Galileo, Simon Marius independently discovered moons around Jupiter, though he did not publish his discovery in a book until 1614. It was Marius's names for the 4 major moons, however, that stuck: Io, Europa, Ganymede, and Callisto. These findings were also the first discovery of celestial motion, not apparently centered on Earth. The discovery was a major point in favor of Copernicus's heliocentric theory of the motions of the planets. Of Jupiter's moons, 8 are regular satellites with prograde and nearly circular orbits that are not greatly inclined with respect to Jupiter's equatorial plane. The Galilean satellites are nearly spherical in shape due to their planetary mass, and so would be considered at least dwarf planets if they were in direct orbit around the Sun. The other 4 regular satellites are much smaller and closer to Jupiter. These serve as sources of the dust that makes up Jupiter's rings. The remainder of Jupiter's moons are irregular satellites whose prograde and retrograde orbits are much farther from Jupiter and have high inclinations and eccentricities. These moons were probably captured by Jupiter from solar orbits. 22 of the irregular satellites have not been officially named. One of the key moons that we must talk about, though, is Europa. For while it may be impossible to settle on Jupiter in the colony sense, the moon of Europa does have potential for being a potential landing spot for humanity jumping across the solar system. Number 6. The potential of Europa. The idea of colonizing a moon is not far-fetched. The problem has always been whether the moon makes sense for us to live on. For example, we can't really live on our moon despite it being so close because it doesn't have an atmosphere, doesn't have much water that we can use. The moon is said to be drier than any desert on Earth, and it doesn't have a natural energy source that we know of that can work in our favor to make things easier to live on it. We can explore it fine as we've shown, but barring advances in technology, it's not a feasible and logical place to live. While Europa is much farther away, it has things we can use to make colonization more plausible. For example, the atmosphere of the moon may be thin, which isn't ideal, but it does have a lot of oxygen, which means we could use that in our colonies to survive. We wouldn't be able to live on the surface without protection, but the air that we could breathe would theoretically be much easier to obtain than on other places. Then, as discovered rather recently, there is water vapor on Europa, with the water being both in the air as well as on the surface via ice and underground plumes. We could use that to help hydrate the colony and potentially even grow things on the surface in the right conditions. There are plenty of other problems that we'd have to deal with, I grant you that. But with water vapor being on the planet, we have a huge next step towards maybe having a colony on another planet, or a moon. Plus, it would be easier living on a moon of Jupiter than on Jupiter itself. After all, it's a very stormy planet with a big spot that you all know about. Number 5. The Great Red Spot. The Great Red Spot is a persistent high-pressure region in the atmosphere of Jupiter, producing an anticyclonic storm, the largest in the solar system, 22 degrees south of Jupiter's equator. It has been continuously observed since 1830. Earlier observations from 1665 to 1713 are believed to be of the same storm. If this is correct, it has existed for at least 360 years. Think about that for a minute. That would mean that a storm has been alive on this planet for hundreds of years, and we here on Earth are mad if stormy weather lasts a few days. The largest and most powerful hurricanes ever recorded on Earth spanned over 1,000 miles across, with winds gusting up to around 200 miles per hour. That's wide enough to stretch across nearly all U.S. states east of Texas. But even that kind of storm is dwarfed by the Great Red Spot. There, gigantic means twice as wide as Earth, with tumultuous winds peaking at about 400 miles per hour. Infrared data have long indicated that the Great Red Spot is colder, and thus higher in altitude than most of the other clouds on the planet. The upper atmosphere above the storm, however, has substantially higher temperatures than the rest of the planet. Acoustic sound waves rising from the turbulence of the storm below have been proposed as an explanation for the heating of this region. As arguably one of the most popular parts of the planet, the Great Red Spot has been studied not just by people on Earth, but via probes and satellites that have passed by Jupiter or have gone to Jupiter just to study it, such as the 2 Voyager probes and the Juno spacecraft. They were able to give true images about the spot, as well as show much of how it worked in terms of rotation, size, and even composition. Though there are still many mysteries about the Great Red Spot, such as how exactly it has that color. Number 4. Rings? When you think about the solar system and the planets themselves, the one planet that you think about when it comes to rings is Saturn. But it was later discovered that while very thin compared to its neighbor, Jupiter does have rings as well. Jupiter has a faint planetary ring system composed of 3 main segments: an inner torus of particles known as the halo, a relatively bright main ring, and an outer gossamer ring. These rings appear to be made of dust rather than ice, as with Saturn's rings. The main ring is probably made of material ejected from the satellites Adrastea and Métis. Material that would normally fall back to the moon is pulled into Jupiter because of its strong gravitational influence. The orbit of the material veers towards Jupiter, and new material is added by additional impacts. In a similar way, the moons Thebe and Amalthea probably produced the two distinct components of the gusty gossamer ring. There is also evidence of a rocky ring strung along Amalthea's orbit which may consist of collisional debris from that moon. What made this a bit shocking was that despite people all knowing about Jupiter, they didn't figure out it had rings until 1979, when the Voyager probe passed by the planet and got pictures of the rings. Number 3. Pop culture. Jupiter also has a large presence in pop culture, including many movies, TV shows, video games, and comics. Jupiter was a notable destination in the Wachowski siblings' science fiction spectacle, Jupiter Ascending, while various Jovian moons provide settings for Cloud Atlas, Futurama, Power Rangers, and Halo, among many others. In Men in Black, when Agent J, played by Will Smith, mentions he thought one of his childhood teachers was from Venus, Agent K, played by Tommy Lee Jones, replies that she is actually from one of Jupiter's moons. And of course, for all of you anime fans, in Sailor Moon, one of the main characters was indeed Sailor Jupiter, a fan favorite character to many. Number 2. What makes up Jupiter? One of the things that defines Jupiter is that it's a true gas giant, the first in the solar system if you talk about the order of the planets, meaning from Mercury to Pluto. Given its many colors and the way it acts, you'd be fine for not knowing all that comprises the biggest planet in our solar system. Jupiter's upper atmosphere is about 88 to 92% hydrogen and 8 to 12% helium by percent volume of gas molecules. A helium atom has about 4 times as much mass as a hydrogen atom, so the composition changes when described as the proportion of mass contributed by different atoms. Thus, Jupiter's atmosphere is approximately 75% hydrogen and 24% helium by mass, with the remaining 1% of the mass consisting of other elements. The atmosphere contains trace amounts of methane, water vapor, ammonia, and silicon-based compounds. There are also traces of carbon, ethane, hydrogen sulfide, neon, oxygen, phosphine, and sulfur. The outermost layer of the atmosphere contains crystals of frozen ammonia. Through infrared and ultraviolet measurements, trace amounts of benzene and other hydrocarbons have also been found. The interior contains denser materials. By mass, it is roughly 71% hydrogen, 24% helium, and 5% other elements. No matter what way you look at it, though, the outcome is the same. It's a massive planet full of gas that we can't live on, in, or near. There's no surface to land on, and because it's a gas giant, we don't even know what its core is like, or even its size. Hence, as noted earlier, people are believing that the moons of Jupiter are a better place to land rather than the planet itself or even its atmosphere. Number 1. Continuing to explore. 9 spacecraft have visited Jupiter over the course of its life and the life of the space program. 7 flew by and 2 have orbited the gas giant. Juno, the most recent, arrived at Jupiter in 2016, but there are more on the way. The next planned mission to the Jovian system will be the Europa Clipper mission in 2023. Why continue to explore Jupiter? Simple. We still don't know everything about the planet. And if we are to habitate one of its moons, we need to learn even more about those moons and how they interact with Jupiter as a whole. So we will continue to explore so that one day we can boldly go where no man has gone before. Number 8. The Finding of Saturn. Believe it or not, Saturn has a long and multi-layered history of being found, and its first appearances are further back in time than you would think. Saturn has been known about since prehistoric times and in early recorded history, as it was a major character in various mythologies. Babylonian astronomers systematically observed and recorded the movements of Saturn. It was also known about to both the Green and Roman cultures, who put them into their pantheons. In ancient Roman mythology, the planet Phainon, Saturn, was sacred to their agricultural god, from which the planet takes its modern name. The Romans considered the god Saturnus the equivalent of the Greek god Cronus. The Greek scientist Ptolemy based his calculations of Saturn's orbit on observations he made while it was in opposition. In Hindu astrology, there are 9 astrological objects known as Navagras. Saturn is known as Shani, and judges everyone based on the good and bad deeds performed in life. A scary thought indeed. Saturn's rings, which we'll talk about more later, require at least a 15mm diameter telescope to resolve, and thus were not known to exist until Christian Huygens saw them in 1659. Galileo, with his primitive telescope in 1610, incorrectly thought of Saturn's appearing not quite round as two moons on Saturn's sides. It was not until Huygens used greater telescopic magnification that this notion was refuted, and the rings were truly seen for the first time. Huygens also discovered Saturn's moon Titan. Giovanni Domenico Cassini later discovered 4 other moons: Iapetus, Rhea, Tethys, and Dion. Number 7. Orbits and seasons. As the 6th planet from the Sun, you would expect certain things from Saturn in terms of its orbits and its seasons, and some of them are true. But not unlike Earth, it has some severe differences in terms of its rotations. Just in regards to a year on Saturn, the ring planet takes 29 years to make it around the Sun. If you time it right, you'll basically live a third of your life before Saturn orbits the Sun once. Yet almost directly like its brother Jupiter, Saturn has a day that's only 10.6 hours long due to its fast rotation on its axis. Now, just as Jupiter has unique kinds of seasons, so does Saturn. But unlike Jupiter, Saturn has to worry about not just its connection to the Sun, but its rings to determine just how hot or cold it'll get. At certain points in its orbit rotation, the rings of Saturn will actually shade the planet, meaning that it'll get cooler. During this point, the intense winds on the planet will decrease by as much as 40%. This says nothing of the intense storms that can occur on the gas giant, and since seasons can last about 8 years on Saturn, that means the shifts can be slow at one point and then rapid in another. Number 6. Moons. The moons of Saturn are numerous and diverse, ranging from tiny moonlets, only tens of meters across, to enormous Titan, which is larger than the planet Mercury. 24 of Saturn's moons are regular satellites. They have prograde orbits not greatly inclined to Saturn's equatorial plane. They include the 7 major satellites, 4 small moons that exist in a Trojan orbit with larger moons, 2 mutually co-orbital moons, and 2 moons that act as shepherds of Saturn's F ring. Number 5. Titan. Titan is a very interesting moon in both the literal and theoretical sense. Many actually believe that it is viable and even a logical place for humanity to touch down to make a colony. Some have even gone so far as to say that Titan should be the place where we go and make our first colony instead of the moon of our own Earth and Mars. Why would we consider going to a place like Titan to be a new home for humanity? There is some hard science that states why Titan might just be a viable place for us to live on, believe it or not. In terms of size, Titan is bigger than you might think. It is the largest moon that orbits Saturn, and it is bigger than our moon and even the planet Mercury. That being said, it's only 40% the size of Earth, so that would be a small problem. Yet we're not talking about inhabiting all the surface of Titan, just enough to get a colony or 2 going. However, what it lacks in space, it makes up for in gases and hydrocarbons, specifically liquid hydrocarbons, which has many scientists thinking that this is a great place to go because the amounts of liquid hydrocarbons that they're seeing on Titan is greater than that of the entirety of Earth. Titan is just covered in carbon-bearing material. It's a giant factory of organic chemicals, said Ralph Lorenz, who leads the study of Titan based on radar data from Cassini. This vast carbon inventory is an important window into the geology and climate history of Titan. Just to give you an image of what you can expect by that statement, there are literal seas and lakes filled with methane, ethane, and other liquid hydrocarbons. Some have been even measured to be bigger than the Great Lakes in the United States. Plus, Titan does have an atmosphere, and one comprised of very familiar elements: oxygen, hydrogen, nitrogen, and methane, all of which are in our own atmosphere here on Earth. Because of this, some scientists have stated that Titan is the most hospitable place in our solar system that humans could survive at. And that's only scratching the surface of what these gases can do for us. For example, while the water on the planet may not be able to be drinkable as it stands, it can be filtered to not only drink but produce more oxygen into the air. And the nitrogen, methane, and ammonia that is within the atmosphere and the planet can be used to make fertilizer, and thus allow us to grow food on the planet when the time comes. Now, yes, there are downsides, the biggest of which is that the moon doesn't have the strongest of gravity, and of course the distance between Earth and Saturn is rather significant, but if these two factors could be overcome, you might just find us shooting for Titan sooner rather than later. Number 4. Atmosphere. Focusing back on the main planet again, what is the atmosphere of Saturn like? The outer atmosphere of Saturn contains 96.3 molecular hydrogen and 3.25 helium by volume. The proportion of helium is significantly deficient compared to the abundance of this element in the Sun. The quantity of elements heavier than helium, metallicity, is not known precisely, but the proportions are assumed to match the primordial abundances from the formation of the solar system, in which Saturn is said to have been formed about 4.5 billion years ago. The total mass of these heavier elements is estimated to be 19 to 31 times the mass of Earth, with a significant fraction located in Saturn's core region. Saturn's atmosphere exhibits a banded pattern similar to Jupiter's, but Saturn's bands are much fainter and are much wider near the equator. The nomenclature used to describe these bands is the same as on Jupiter. Saturn's finer cloud patterns were not observed until the flybys of the Voyager spacecraft during the 1980s. Since then, Earth-based telescopy has improved to the point where regular observations can be made, which of course we make full use of when we can. Saturn's usually bland atmosphere occasionally exhibits long-lived ovals and other features common on Jupiter. In 1990, the Hubble Space Telescope imaged an enormous white cloud near Saturn's equator that was not present during the Voyager encounters, and in 1994 another smaller storm was observed. The 1990 storm was an example of a great white spot, a unique but short-lived phenomenon that occurs once every Saturnian year, roughly every 30 Earth years, around the time of the Northern Hemisphere's summer solstice. Previous great white spots were observed in 1876, 1903, 1933, and 1960, with the 1933 storm being the most famous. If the periodicity is maintained, another storm will occur, possibly in 2020. The winds on Saturn are the second fastest among the solar system's planets after Neptune's. Voyager data indicate peak easterly winds of 500 meters per second, or 1,800 kilometers per hour. Number 3. The spacecraft around Saturn. As we are a curious race, Saturn has had many probes and spacecraft study it over the years since we've been able to launch things into space. Pioneer 11 made the first flyby of Saturn in September of 1979, when it passed within 20,000 kilometers of the planet's cloud tops. Images were taken of the planet and a few of its moons, although their resolution was too low to discern surface detail. The spacecraft also studied Saturn's rings, revealing the thin F ring, and the fact that dark gaps in the rings are bright when viewed at high phase angle towards the Sun, meaning that they contain fine light scattering material. In addition, Pioneer 11 measured the temperature of Titan, which, as we've noted, is a key part of Saturn's value. In November 1980, the Voyager 1 probe visited the Saturn system. It sent back the first high-resolution images of the planet, its rings, and satellites. Surface features of various moons were seen for the first time. Voyager 1 performed a close flyby of Titan, increasing knowledge of the atmosphere of the moon. It proved that Titan's atmosphere is impenetrable in visible wavelengths. Therefore, no surface details were seen. The flyby changed the spacecraft's trajectory out from the plane of the solar system. Almost a year later, in August of 1981, Voyager 2 continued the study of the Saturn system. More close-up images of Saturn's moons were acquired, as well as evidence of changes in the atmosphere and the rings. Unfortunately, during the flyby, the probe's turnable camera platform stuck for a couple of days, and some planned imaging was lost. Saturn's gravity was used to direct the spacecraft's trajectory towards Uranus. Finally, there was the Cassini-Huygens space probe that entered orbit around Saturn on July 1, 2004. It went to the moon Phoebe and sent back some images and data of the moon. It also discovered various things about Titan, tracked lightning on Saturn itself, and more. Number 2. Pop culture. Perhaps the most iconic of all the planets in our solar system, Saturn is heavily present in pop culture, no doubt because of how much people love the planet in one form or another. It provides a backdrop for numerous science fiction stories, movies and TV shows, comics and video games, including the Cthulhu mythos, WALL-E, 2001: A Space Odyssey, Star Trek, Dead Space 2, and Final Fantasy VII. In Tim Burton's film Beetlejuice, a dusty, fictional Saturn is populated by giant sandworms. And in the 2014 movie Interstellar, the wormhole that enables the astronauts to travel to another galaxy appears near Saturn. Saturn is also the namesake of Saturday, arguably the best day of the week. See? Your favorite planet helped inspire your favorite day. Cool, huh? Number 1. The rings. Without a doubt, when you think of Saturn, you think of the many wonderful and beautiful rings that surround the planet. They are easily the most noticeable of the 4 ringed planets in our solar system. Saturn's rings are thought to be pieces of comets, asteroids, or shattered moons that broke up before they reached the planet, torn apart by Saturn's powerful gravity. They are made of billions of small chunks of ice and rock coated with another material, such as dust. The ring particles mostly range from tiny, dust-sized, icy grains to chunks as big as a house. A few particles are as large as mountains. The rings would look mostly white if you looked at them from the cloud tops of Saturn, and interestingly, each ring orbits at a different speed around the planet. Saturn's ring system extends up to 175,000 miles, or 282,000 kilometers from the planet, yet the vertical height is typically about 30 feet, or 10 meters, in the main rings. Named alphabetically in the order they were discovered, the rings are relatively close to each other, with the exception of a gap measuring 2,920 miles, or 4,700 kilometers wide, called the Cassini division, that separates rings A and B. The main rings are A, B, and C. Rings D, E, F, and G are fainter and more recently discovered. Starting at Saturn and moving outward, there is the D ring, C ring, B ring, Cassini division, A ring, F ring, G ring, and finally the E ring. Much farther out, there is the very faint Phoebe ring in the orbit of Saturn's moon Phoebe. We are fascinated by the rings of Saturn, especially when it was later discovered that Jupiter, Uranus, and Neptune also had rings of various sizes and natures. We've also found planets and galaxies far, far away that have ring systems that are massive even when compared to Saturn. One planet is even named Super Saturn because of how big its rings are. Number 9. Its discovery. Before diving into the various facts about Uranus and how it quite possibly became what it is today, we need to first understand how it got discovered, because it's a tale that is rather familiar when it comes to the outer planets. You see, Uranus has been observed on many occasions before its recognition as a planet, but it was generally mistaken for a star. Many other planets and dwarf planets had similar misidentifications because of their distance from the Sun and the Earth and their slow orbits. More on that later. Possibly the earliest known observation was by Hipparchus, who in 128 BC might have recorded it as a star for his star catalog that was later incorporated into Ptolemy's Almagest. The earliest definite sighting was in 1690 when John Flamsteed observed it at least 6 times, cataloging it as 34 Tauri. The French astronomer Pierre-Charles Lemonnier observed Uranus at least 12 times between 1750 and 1769, including on 4 consecutive nights. Oh, but it didn't stop there though, far from it. Sir William Herschel observed Uranus on March 13, 1781, from the garden of his house in Bath, Somerset, England, which is now the Herschel Museum of Astronomy, and initially reported it in April 1781 as a comet. With a telescope, Herschel engaged in a series of observations on the parallax of the fixed stars. This is infinitely ironic because of the fame of Herschel and his discoveries of other major celestial objects in the sky. But most of all, he kept asserting it was a comet to everyone that mattered, although one time he did liken it to a planet. The power I had on when I first saw the comet was 227. From experience, I know that the diameters of the fixed stars are not proportionately magnified with their higher powers as planets are. Therefore, I now put the powers at 460 and 932, and found that the diameter of the comet increased in proportion to the power it ought to be, on the supposition of it not being a fixed star, while the diameters of the stars to which I compared it were not increased in the same ratio. Moreover, the comet, being magnified much beyond what its light would admit of, appeared hazy and ill-defined with these great powers, while the stars preserved that luster and distinctness which from many thousand observations I knew they would retain. The sequel has shown that my surmises were well founded, this proving to be the comet we have lately observed. Oops, things only got worse later on. Herschel notified the astronomer Royal Neville Maskelyne of his discovery and received this flummoxed reply from him. "I don't know what to call it. It is as likely to be a regular planet moving in an orbit nearly circular to the Sun as a comet moving in a very eccentric ellipsis. I have not yet seen any comma or tail to it." Herschel, though, refused to believe it was anything other than a comet, but other astronomers out there were starting to get wise to the fact that this could be something else, like, a planet. Finnish-Swedish astronomer Anders Johan Lexell, working in Russia, was the first to compute the orbit of the new object. Its nearly circular orbit led him to a conclusion that it was a planet rather than a comet. Berlin astronomer Johann Elert Bode described Herschel's discovery as a moving star that can be deemed a hitherto unknown planet-like object circulating beyond the orbit of Saturn. Bode concluded that its near-circular orbit was more like a planet's than a comet's. The object was soon universally accepted as a new planet, and even Herschel had to admit it after a while and note to Joseph Banks that he was wrong and that other astronomers had done right by labeling it a planet. Astronomy wasn't what it is right now back then. Their technologies mixed with their understanding of the universe was limited. For them to find Uranus and track its movements in 1781 is astounding, so it's understandable that they could get the classification wrong. Number 8. Its name. When you think about the seventh planet from the Sun, your eyes and mind no doubt go to its name, Uranus, which, as we'll explain later, has become the butt of many jokes. But back when the planet was truly found, that wasn't the intention at all. The name of Uranus references the ancient Greek deity of the sky, Uranus, the father of Cronus, Saturn, and grandfather of Zeus, Jupiter. Consensus on the name was not reached until almost 70 years after the planet's discovery, which is a very long time when you consider how long the other planets took to get their name. During the original discussions following discovery, Maskelyne asked Herschel to do the astronomical world the favor to give a name to your planet, which is entirely your own, and which we are so much obliged to you for the discovery of. In response to Maskelyne's request, Herschel decided to name the object Georgium Sidus, George's star, or the Georgian planet, in honor of his new patron king, George III. He explained this decision in a letter to Joseph Banks. In the fabulous ages of ancient times, the appellations of Mercury, Venus, Mars, Jupiter, and Saturn were given to the planets, as being the names of their principal heroes and divinities. In the present more philosophical era, it would hardly be allowable to have recourse to the same method and call it Juno, Pallas, Apollo, or Minerva for a name to our new heavenly body. The first consideration of any particular event or remarkable incident seems to be its chronology, if in any future age it should be asked when this last found planet was discovered. It would be a very satisfactory answer to say, in the reign of King George III. While that may have seemed logical to him, the rest of the world didn't agree, mainly because it was a British king getting the name and the rest of the world didn't think that was right. Thus, other names were suggested by people from all over. Ironically, someone thought it should be named Herschel, because it was he who discovered it. Just as ironic, someone felt it would be good to name it Neptune, and had a lot of support around that name. In a March 1782 treatise, Bode proposed Uranus, the Latinized version of the Greek god of the sky, Uranus. Bode argued that the same should follow the mythology so as not to stand out as different from the other planets, and that Uranus was an appropriate name as the father of the first generation of the Titans. He also noted that elegance of the name in that just as Saturn was the father of Jupiter, the new planet should be named after the father of Saturn. Many agreed, and thus Uranus was the most widely accepted name. However, because of a holdout, the HM Nautical Almanac Office, the name was not truly universally accepted until 1850. So as you can see, finding a planet is hard. Naming a planet in those days, that was even harder in some ways. Number 7. Orbits and rotations and seasons. Focusing now on the planet itself, Uranus is a dichotomy of curiosity when it comes to its orbits and rotations. Why is that? Because if you look at its daily rotation, it's only 17 hours long, which means a day there isn't even as long as a day on Earth. However, when you get into its orbit around the Sun, it takes 84 years to go one full rotation. Think about that. That means that one full orbit for Uranus can be equivalent to an entire human life, if not longer when you look at the average of it all. This, combined with its unique tilt, also makes the planet very unique in terms of its seasons. The planet's North Pole experiences 21 years of nighttime in winter, 21 years of daytime in summer, and 42 years of day and night in the spring and fall. Number 6. Funny tilt. As the series Schoolhouse Rock adequately noted in their song Inner Planet Janet, Uranus is built on a funny tilt, which is 100% accurate because unlike every single planet in our solar system, Uranus is sideways in the literal fashion. This was proven by many metrics, but the biggest one being its rings. They're perfectly vertical, unlike Saturn or other planets we know of that have horizontal rings most times. Furthermore, this was proven when studying its axes, which are tilted 98 degrees, relative to the plane of the solar system, meaning it essentially spins on its side. No other planet in the solar system is tilted as much. Jupiter is tilted by about 3 degrees, for example, and Earth by about 23 degrees. But what caused this? No one is really sure. However, certain scientists and astronomers from Japan suggest that a cosmic impact may be to blame. Not only that, they think that this cosmic impact could have not just put Uranus on a funny tilt, but also helped make its many moons. Given that none of the other planets in our solar system have this kind of a tilt, it's fair to say that they might be right in their notion of an impact causing Uranus to be like this. Number 5. Atmosphere. Uranus's atmosphere is mostly hydrogen and helium, with a small amount of methane and traces of water and ammonia. This methane gives Uranus its signature blue color. While the probe Voyager 2 saw only a few discrete clouds, a great dark spot, and a small dark spot during its flyby in 1986. More recent observations reveal that Uranus exhibits dynamic clouds as it approaches equinox, including rapidly changing bright features. Uranus's planetary atmosphere, with a minimum temperature of 49 Kelvin, minus 224.2 degrees Celsius, makes it even colder than Neptune in some places. Wind speeds can reach up to 560 miles per hour or 900 kilometers per hour on Uranus. Winds are retrograde at the equator, blowing in the reverse direction of the planet's rotation. But closer to the poles, winds shift to a prograde direction, flowing with Uranus's rotation. Number 4. Pop culture. Uranus is the butt of more than a few jokes and witty and not so witty puns, but it's also a frequent destination in various fictional stories, such as the video game Mass Effect and TV shows like Doctor Who. The radioactive element uranium was named after Uranus when it was discovered in 1789, just 8 years after the planet was discovered. In anime, Uranus has a very special place in history via the show Sailor Moon. Uranus was one of 2 sailors who came later in the series, and the character of Uranus was gay alongside Neptune. But in the American version of the show, they were cousins. What's more, as if to showcase the uniqueness of Uranus and show that she, like the planet, was sideways in certain measures, she dressed like a guy when not in fighter form by wearing suits. In the sports world, on the show Pardon the Interruption, host Tony Kornheiser wastes no chance to make a Uranus joke. Why? Because he can and he loves to do it. And he's not the only one, as we've noted. Even Mass Effect had a bit where they had a Uranus joke when you probe the planet for materials in Mass Effect 2. Because of its name, regardless of the origins and meaning of it, Uranus will always be made fun of by those who want a quick joke. Number 3. Magnetosphere. Uranus has an unusual, irregularly shaped magnetosphere. Magnetic fields are typically in alignment with a planet's rotation, but Uranus's magnetic field is tipped over. The magnetic axis is tilted nearly 60 degrees from the planet's axis of rotation, and is also offset from the center of the planet by 1/3 of the planet's radius. Auroras on Uranus are not in line with the poles like they are on Earth, Jupiter, and Saturn due to the lopsided magnetic field. The magnetosphere tail behind Uranus opposite the Sun extends into space for millions of miles. Its magnetic field lines are twisted by Uranus's sideways rotation into a long corkscrew shape. Number 2. Rings. Uranus has 2 sets of rings. The inner system of 9 rings consists mostly of narrow, dark gray rings. There are 2 outer rings. The innermost one is reddish like dusty rings elsewhere in the solar system, and the outer ring is blue like Saturn's E ring. In order of increasing distance from the planet, the rings are called Zeta, 6, 5, 4, Alpha, Beta, Eta, Gamma, Delta, Lambda, Epsilon, Nu, and Mu. Some of the larger rings are surrounded by belts of fine dust. Number 1. Moons. Uranus is one of many planets in our solar system that have many moons. At present count, it has 27. Their composition is stated to be half water ice and half rock, which could have some potential for things in the future if we're able to study them and get closer than we can right now. Another thing that separates the moons of Uranus from others is that their names are different. If you look at the grand scale of the solar system we're in, you'll see that the planets and moons that are named are gods, deities, and other beings of mythology. But not Uranus. Its moons are named after Shakespearean characters and ones written by Alexander Pope, showing that even when it comes to names, Uranus is not like the other planets.